Assalamualaikum everyone. So today my teammates and I are going to present to you about instruction cycle of AMD Ryzen. First of all, I am going to tell you about the abstract of this project. What is the definition of instruction cycle? Instruction cycle is the cycle that the central processing unit CPU follows from boot up until the computer has shut down in order to process instruction. Here, I include two highlights of Zen 5 architecture, which are improved core design and faster performance compared to earlier models, and the second one is enhanced technique like pipelining, out of order execution, and branch prediction. The performance impact. It will optimize instruction handling for better gaming, multitasking, and complex computation, and provide faster, more efficient processing in AMD Ryzen 5 processor. These are the Ryzen 5 overview. It is a line of mid-range processor by AMD built on the Zen micro architecture. This focus on high performance and power efficiency, and popular for gaming, content creation, and multitasking. There are 4 steps of instruction cycle basics, which are fetch, decode, execute, and store. These steps are essential for quick and efficient data processing. The enhancements of Zen 5. The features like pipelining, out of order execution, and branch prediction. It also contains superscalar architecture for parallel instruction processing. This is an overview of the diagram referring the instruction cycle of AMD Ryzen Zen 5. The next slide will be continued by Faiz and Luffy for more explanation regarding the diagram.
And today I'm going to talk about the fetch decode unit and execution unit. So first thing first, fetch/decode unit. There are 4 parts that I'm going to highlight when it comes to those 2 units. For fetch decode unit, I'm going to talk about branch prediction, instruction fetching, decode process, and micro up-queue and rename. So the first one, branch prediction. The AMD Zen 5 processor utilizes a branch predictor to anticipate the direction of branches in the instruction stream, with minimizing delays caused by missed predictions. This branch prediction only works with fast access structures for efficient handling of complex branch patterns. Secondly, instruction fetching. The instructions from instruction fetching are fetched from a 32 kilobytes an 8-way set associated L1 instruction cache at a rate of 32 bytes per cycle. If those were not available in the L1 cache, the request will escalate to the L2 cache and so on and so forth. The third one, decoding process. The processor features from AMD Zen 5 is the feature. So the processor from AMD Zen 5 are features with 4-way decoders that can process up to 4 instructions per cycle. By converting complex CICS instruction into a simpler micro operation, or shortened for micro ops, with microcode ROM used when direct decoding is not possible. And last but not least, micro up-queue and renaming. As soon as decoding process was over, the micro ops would enter the micro up queue for buffering before being mapped from architectural to physical register in the register alias table, also known as RAT. This only allows for up to 8 micro ops to be renamed and dispatched every cycle for the execution unit. Speaking of the execution unit, there are also four parts that I'm going to highlight with, which is execution engine functionality, micro-op tracking and retirement, efficient resource utilization, and interaction with cache. So first one, execution engine functionality. So the execution engine in AMD Zen 5 were were tests for executing decoded micro operations using a specialized pipelines to ensure that different types of operation, which consists of integer, memory, float point, are dispatched to their respective schedulers. Secondly, micro-op tracking and retirement. The micro-ops are managed in the recorder buffer or ROB to track execution status and ensure that they are retired in program order for maintaining correctness while allowing out of order execution for increased throughput. The third one, efficient resource utilization. The architecture from efficient resource utilization incorporates optimization techniques like move elimination and zeroing idioms to enhance performance by minimizing unnecessary data movement and efficiently utilizes values, which means that they would minimizing some unnecessary data to make sure that the execution unit would function very well. And last but not least, interaction with caches. So the interaction with caches we're, we're using was using load store microops to interact with the L1 data cache, and in those events of cache miss, requests escalate to a higher cache levels or memory that data to ensure the data availability were visible. And that's all for me. And to continue my presentation, I would like to give my presentation to Ahmad Lufu.
Okay, now I'm going to talk about memory cache unit. Multi-level cache hierarchy. AMD Ryzen Zen 5 processors feature a multi-level cache system, including L1, which is 48 KB, L2 1 MB, and L3 8 MB or 6 MB cache, optimizing low latency data access and ensuring efficiency data flow between execution unit and memory. The second is efficient cache operation. The L1 data cache handle fast access with a throughput of up to 64 bytes per cycle. If a cache miss occurs, requests cascade through L2 and L3 cache with a missed address buffer, prioritizing requests to reduce costly access to main memory. And after this, we have the address translations and prefetching. The system employs translations log aside buffers for efficient virtual to physical address translations along with prefetching mechanism to load data in advance, further reducing latency for memory intensive application. And last, we have a superscala processing. AMD Ryzen 5 CPU utilizes superscala architecture, allowing multiple execution units to process several instructions per clock cycle. They enhance performance for multitasking, gaming, and productivity implement in model like Ryzen 3600, 5600X, and 7600X. In conclusion, Zen 5 core advantage designed for fast and efficient performance through enhanced instruction cycle stage. Performance highlight excel in gaming, multitasking, and complex calculations. Deliver enhanced speed, power, efficiency, and responsiveness. And the third one is key technology, pipelining faster and processing with overlapping stage out of order execution, reduce delay of executing tasks as resources become available. Branch predictions anticipate instruction flow for smoother operation. And the last thing is user experience. Support running application, heavy project and high demand tasks seamlessly. And that's all from our presentation. Thank you for watching this video.